With atoms and the arrangement of the periodic table. This is the periodic table. This is a figure out of your text. Notice that on these we have the atomic numbers. So that's your atomic number, which tells you the number of protons. Okay, but this one doesn't have the mass. It just has the elements, and it has metals, nonmetals. We'll get to that as we go. So we're going to basically, this is a handout I used to have on periodic table. We're going to be able to look at these different things. This is the basic arrangement of the periodic table. If you look at it, technically these should slide in right here, but that makes the periodic table humongous. So they've basically taken those out and shifted them below. More about what they are. When we're through identifying the pieces parts, you'll be able to recognize the pieces parts, which is more critical than memorizing the periodic table. So the first thing we need to do is talk about the periodic table. Dmitry Mendeleev was the first guy to organize it. He was a Russian. At the institution that he worked at, they have his basic starting points of the periodic table on the wall of the building. His old apartment is a museum because it was for post-it notes. But basically, he taped little thoughts all over the walls. So if you ever go to Russia, it might be worth going by and seeing it. So in general, the periodic table is arranged with periods or rows in the horizontal lines going side to side. If you're going up and down, we call those families or groups. So if we talk about a family, we're talking about them. Okay, why is this not wanting to erase more for me? Fine, it's going to misbehave. So a family or group, and that goes up and down. Think of family groups as you're like your family tree. That's the up and down. Now, on every periodic table, you should have a zigzag line. The one I gave you or posted, you have to write it in. But I'll show you where it goes. And that's going to differentiate. Metals are going to lie to the left of the zigzag line. Okay, nonmetals lie to the right of the zigzag line. And metalloids, or semimetals, are on the zigzag line. So why is that important? Because they act differently. Metals are the main class, then nonmetals, and then metalloids have some properties of metals and some properties of nonmetals. So if we look at our species, if you'll notice, they're color coded. The blue are the main group. So main group or representative. Elements. So representative elements. Okay, so those are the blue ones. More about why they're arranged the way they are when we get to electronic configurations, but hang with me right now. So this group here are the transition metals. And here are the inner transition metals. Also known as the lanthanides and actinide series. Okay, so when we talk about elements or atoms. We may say we're just talking about the main group. Sometimes we're talking about just the transition metals or the intertransition metals, and we'll identify those as we go. Now, some of the families are really critical on the periodic table. But notice first that I put in the zigzag line. So that's your zigzag line. And yes, that's exactly what it's called. It's a zigzag line. And it starts at boron and goes down. So when we talk about things being on the zigzag line, that means they're touching it. Okay, so over here are your nonmetals. Over here are your metals. Some of the species are looked at often enough that you have to know their specific names. So these metals are the alkali metals. That's group 1. Okay, the alkaline earth metals are group 2. Now remember, these are the transitions, and we're going to ignore those for specific family names. Okay, there are some amongst that, but you don't really want to know them. So we're going to go ahead and go backwards here. These are the noble gases, or the inert gases, and they're called that because they don't react. Again, more about that later. The group starting with fluoride on down, these are the halogens, and these are, this one started helium. The halogens are a unique family. They're heavily involved in a lot of reactions and compounds that we use. The next group, starting with oxygens, are the chalcogens. This is an old name. These are the chalk formers. You don't see this particular name all over the place, but it's different, and so I like to keep it. So you may be asked to ID a species. So for example, if I gave you potassium and asked, is it in a particular family, you would say that it is in the alkali metals. Yeah, and that was so badly spelled. Alkali metals. Okay. On the other hand, sulfur is a chalcogen. Chlorine, if you look at it where it's arranged, it's a halogen. Krypton is a noble gas. So you may be given a different species and ask the question, and I may say, what is boron? You would say it's a metalloid or a semi-metal. Okay, sodium would be a metal. Phosphorus would be a nonmetal. So you'll be asked to ID different aspects on the periodic table, but you're not going to be asked to come up with it on your own. You just look at it on the periodic table. So that brings us to the last point here, is what are coins made of, because coins are made of the coinage metals. But this is an interesting little lagniappe to read through. And in the next section, we'll take it a step farther and go with compounds.